Thanks for tuning in. Today we'll be talking about top 5 MQTT features, and from my point of view, the most important one. And also it starts the series about the industry, Internet of Things, and UNS specifically. So hope you will enjoy it. And with that, let's figure it out. Hierarchical namespace is by far the most important one. And it basically defines the structure of the nature of MQTT. What you see in the screen here is two applications and one broker, and MQTT protocol is PubSub protocol, which means there is no direct communication between the clients, but actually there is only communication through the broker that distributes the communication according to the subscriptions. And in this case, there is a publisher that has certain topics defined, which basically defines the structure, how it lands on the broker side, and when the client, and then there is application that subscribes to it, which, for example, in this case, interested only in temperature and not interested in pressure. And when temperature will arrive to the broker from the publisher, then the broker will forward the message to the client. And that's basically how interaction happens. Which makes the MQTT powerful is basically the subscription to not just exactly one thing, but just the hierarchy of things. In this case, let's say you are interested only in location 6 information, which means everything that falls underneath will be automatically consumed by the subscriber. And in this case, if something new happened, like serial number was added on the publisher side, it automatically will be, the telemetry will automatically be propagated to the client application, because it's dynamic nature of MQTT that the application that subscribes to the data will receive the information automatically without explicitly asking for the new metadata updates. The next thing which is important, and it's hard not to use this feature in MQTT, is called retained messages. This one comes out of the trade-off that MQTT as a protocol need to make, because when you have high throughput broker, you have to drop the messages that other clients are not interested in, and retained message prevent to drop the messages just in case you have the scenario that you want to use them. And again, let's just check it by example. So here what you see is again the publisher that publishes the topics, but this time it will mark one of the messages that it publishes with a retained flag. And when broker receives it, when new telemetry is published which is not marked with a retained, you see there is no subscriber here, so that the information about like the value that it received by broker will be dropped. In case new client will arrive and it will subscribe to both temperature and config, then the config will be sent, but temperature obviously is already dropped, so no value will be received for that client. And that's exactly the nature of MQTT, that for the scenarios where you need, and that's why I marked it as a config. Commonly that's the case for configuration, when you want new clients that appeared and connected to the broker to receive certain configuration. That's commonly marked as retained and preserved on the broker side, and then you can retrieve this information from the client application. Moving next one, this one is called persistent session, and this, as you see, the diagram became a bit more complex. This time what we have is one publisher, broker obviously, and two subscribers this time. And the difference between those clients is basically in the subscription mechanism, how they want to subscribe to the broker. And this one is obviously about how persistent the session is. In this case, what we see is one client is persistent one is non-persistent. What it technically means, let's again see by example. One client publisher publishes the message, and as soon as everything is connected, it doesn't matter, persistent or not, they will receive the messages, and broker obviously will discard those messages from its side. But then the interesting parts start happening. On the disconnect, when new message arrives, it will be stored in the queue for the client 1, but it won't be stored for client 2 because it's not persistent. And what happens after the restoration of the connection is that this message will be sent to the persistent session, but other client will not receive this message. And when the third message obviously arrives, everything is connected, so the third message will appear. And just by a simple comparison of the left and right, you obviously see that the second message was dropped. So again, it can be desired or not desired, or acceptable, not acceptable to lose these messages. In case it's more transactional kind of interaction between the applications, obviously the persistent session is a must-have. But in case you're fine to lose the telemetry, like temperature or some sensor information that is not as critical for you, then you can use non-persistent session, because like always there is a trade-off, and the trade-off is obviously the performance and load on the broker side. So if everything will be made a persistent session, then broker have to handle the queues, and it will be more load and more requirements from the hardware perspective on the broker side. The fourth one, called shared subscriptions, it's in a nutshell the load balancing mechanism for MQTT, and the load balancer in this case is MQTT broker. So again, one publisher, two clients, broker in between, and we're sending the messages. But this time the difference is that instead of just subscribing to the same hierarchical structure, you append two things on top of the hierarchy. One is just the identification that this is shared subscription, and the second one, in this case it's service 1, just identifies that certain instances of the application that will be subscribing will need to fall in the load balancing group here. So you see here is just logical definition of service 1 group. And also service 1 load balancer, I call it in brackets, right? There is no technically load balancer inside, but it's just the way how logically the load is distributed. In this case, the temperature is published to the broker, message 1, then it gets distributed to client 2, queue in the end, if it's persistent session, and then it gets distributed to the client 2. And then obviously, when you receive the message 2, it gets distributed to client 1, and then client 1 receives the message 2. And basically, that's the load balancing mechanism. And if you think about it, that's basically allows the horizontal scaling without any programmatic overhead, right? You just write the same application that you specify shared subscription to monitor specific topical structure, and then all applications, as soon as they come online, start monitoring this stuff. And it's very easy load balancing mechanism from application. The last one is pretty easy one, but I don't think that you can work around it, and you have to know about the quality of service in MQTT for exactly one reason, that previous features require quality of service 1. But let's start from the beginning. So quality of service 0 is basically the way, or quality of service in general, right? It's the way how clients care about what they've sent, whether they receive some acknowledgement from the place where they sent it or not. In this case, quality of service 0 tells that MQTT broker client sends the telemetry and does not care about any delivery guarantees from the broker side. And then the quality of service 1, or at least once delivery, meaning that we send the data to the broker and we expect and we need acknowledgement, but it allows the duplicates to be sent. In case of certain timeout, the MQTT client will be allowed to send to the broker one more time, and it will result in the duplicates from the broker side. It will consider it as a new message, and then this message will be handed over to the clients to handle the duplicates. And then if you really need the exactly once delivery, then the more complex and 4 steps process kicks in with quality of service 2. And that's basically, you see here is like acknowledgement on acknowledgement and acknowledgement on acknowledgement on acknowledgement, which is the most robust communication that you can think of, and obviously the slowest one because it really slows down the communication. And in our performance tests that we've done, we really could not use the quality of service 2 because it made the things much slower than at least quality of service 1. So in case you need the robustness, quality of 2. In case you don't care, quality of 0. And the middle ground is always the most tempting one, so please choose wisely. Thank you. That were top 5 MQTT features that you need to consider when choosing MQTT. So choose wisely. Let me know in the comments what are things that I missed and what things that you would like to see the deep dives on, and I will try to make it happen. See you.